Hi students, all of you welcome. Welcome to Sunil Engineering Academy. I am Sunil Kumar Bandaru. Students, recently we have completed the topic in chemistry, acids, bases and salts. Now we are going to discuss the next topic, that is metals and non-metals, which is very important for our competitive examination. Okay, let me start the session, guys. First of all, we are going to discuss about metals. Metals. You know very well about the metals. Metals are very hard and ductile. They allows the electricity, okay, and they also allows the heat through it. For example, you can say aluminum is the metal, copper, iron, sodium, magnesium, calcium, all these are metals. Okay, so we know very well all the metals are solid nature except mercury. Mercury is in the liquid format. So we can say mercury is a liquid metal. Okay. So note down the point. Metals are hard, ductile. What is meant by ductile? Which enables us to make a thin wires. So you can note down here. Ductility means, or ductile means, which enables us to make thin wires. Okay, in this, gold is the most ductile among all the metals. So we can make very thin wires by using the gold. Very important question. Okay, so metals are hard, ductile, good conductors of electricity and heat. Good conductors of electricity and also the heat. Okay, they allows the electricity and also heat. Why they allows the electricity? Because metals having the free electrons, that's why they allows the electricity through it. Very important point that also. You can say the example: iron, copper, aluminium, like 1A elements, group 1A elements, sodium, potassium, magnesium, calcium, rubidium, all those are nothing but considered as the metals. Okay, so here we have note one important point: mercury, that is Hg, is liquid metal. Remaining all are solid format. Meaning all metals are solids. Okay, and coming to some important points of this metal, that is important properties of this metal. Let us take some chemical properties. Chemical properties. That means if the metals react with oxygen, what will happen? If the metals react with water, what will happen? That is a common format. Okay. So now coming to the first one, reaction with oxygen. Reaction with oxygen. Okay. So whenever the metals react with oxygen, they will form as metal oxides. They form metal oxides. For example, I am taking any one metal, copper, react with oxygen, it will become copper oxide. Okay, so to balance the equation, I am going to take 2 here, now 2 here. For example, if the calcium is react with oxygen, again calcium oxide is formed. So 2, I am taking 2 here. Okay. So whenever the metals react with oxygen, their metal oxides will be formed. Okay. And these metal oxides always basic in nature. Metal oxides are basic in nature. That means they are having a base properties. Okay, so here also you can note down one important point. One important point. Note: metals are basic in nature. Basic in nature. Non-metals acidic in nature. Very important. Non-metals acidic in nature. Okay, non-metals are acidic in nature. Now coming to the next one, reaction of metals with water. Second important property, reaction of metals with water. Okay, so if the metals react with water, then again metal oxides are formed, and here the very important thing is hydrogen gas is released. That is the important here. Hydrogen gas is released. It is the important for exams. They will give the question like whenever the water react with metal or metal react with water, which gas is produced? That is hydrogen gas. Okay. Let us take one example. Calcium with water. You will get metal oxide or hydroxide, calcium oxide plus hydrogen gas is released. Again this calcium oxide is react with water, then you will get calcium hydroxide. Calcium hydroxide. That means from this one what you can say? Whenever metal oxide is the metal oxide now. So let us take downside of that one only. Calcium oxide is the metal oxide. Metal oxide react with water, then you will get metal hydroxide. Metal hydroxide. Okay, metal hydroxide. And the next one, here one exception point is that some metals like sodium comma potassium, how they react with water? They will be dangerously react with water or vigorously react with the water. Okay, so some metals like sodium comma potassium reacts vigorously, that means violently, like a bomb. Okay, vigorously with cold water. You can see some experiments in the YouTube. If you search with sodium reaction with water, cold water, okay, you can get a lot of videos. In that you can observe that whenever you drop some amount of pure sodium into the cold water, within a little bit time it will be blasted. Okay, so why? Because it is react vigorously with the cold water. Okay, vigorously with the cold water. Why? Because why it happened? Because lot of energy is released. Whenever the sodium react with water, then you will get NaOH plus some hydrogen gas is released, and apart from that some heat energy is released. Okay, some heat energy is released. So due to this heat energy, it reacts like a bomb. Okay, sodium, okay, and H2O. 3 hydrogens are there, means you have to take 2 here. Now 4. Now here you have to take 2. So hydrogens are balanced, oxygens are balanced, but sodiums we have to take 2. Okay, equation also balanced. So the very important point, some metals like sodium, potassium reacts vigorously with respect to cold water. And if you can consider magnesium, magnesium may not react with cold water, but it reacts with the hot water. Okay, Magnesium does not react with cold water. It react with hot water. Okay, it react with hot water. Okay, these are the very important points for exams. After this, we are going to discuss each and every element that is which are useful for examination only, like sodium and its compounds, magnesium and its compounds, potassium and its compounds, like aluminum its compounds, iron, copper and its compounds are ores. Those are very important for exams. So we want to discuss those. Okay. Now coming to the first one, sodium and its compounds. Sodium and its compounds. Okay, sodium and its compounds are very, very important. You know very well about this sodium. We denote like 11, 23. That means 11 is nothing but atomic number is 11 and mass number is 23. Mass number is 23. And you know very well it is a already I have given it whenever it is react with what, that is vigorously react with what, that means highly reactive. It is the highly reactive or its reactivity is high because of high reactivity. High reactivity, sodium always found in combined form. Combined form. Why? Because it is quickly react. Okay, combined form. So those combinations, first one, NaCl. NaCl. We call it one, this one as sodium chloride. Sodium chloride. Okay, in general it is called as common salt. Very important. The following, which is a common salt or table salt or rock salt, that is nothing but sodium chloride. Coming to the second one, sodium hydroxide, NaOH. Sodium hydroxide, NaOH. It is also called as caustic soda. Caustic soda. We know very well it is the strongest base, guys. It is the strongest base having pH value nearly 14. Okay, and it is especially used in case of by making soaps and detergents. Okay, and also used as the drain cleaning agent. Okay, students, I have already made this metals and non-metals both theory and MCQs, nearly 5 sessions, 2 sessions theory, 3 sessions MCQs. But what is the problem is that those sessions are recorded, but only video is coming, voice is not coming. Okay, so due to that some delay, so I have again doing all these sessions. Uh, Otherwise, already 5 sessions completed, but unfortunately, I have to do again. Uh, Coming to the next one, NaCl, NaOH, and Na2CO3, sodium carbonate. Sodium carbonate. Okay, so here sodium carbonate with water Na2CO3 10H2O is called as washing soda. Very important for exams. Washing soda chemical formula Na2CO3 10H2O. It is used for washing purpose. Okay, now coming to the next one, NaHCO3. This is called as sodium bicarbonate, bicarbonate or sodium hydrogen carbonate, hydrogen carbonate. Okay, so what is the name of the sodium bicarbonate in general terms? B for baking, B for baking soda. Sodium bicarbonate is nothing but baking soda. So they will ask the question like baking soda chemical formula NaHCO3. NaHCO3. Okay. So NaCl sodium chloride, NaOH sodium hydroxide or caustic soda, Na2CO3 10H2 is the washing soda, NaHCO3 is the sodium bicarbonate, B for baking soda. Okay. Used in cooking purpose. Now coming to the next one, Na2SO4 sodium sulfate with 10H2O is also called as hypo, is also called as hypo, sodium thiosulfate, sodium thiosulfate. Okay, where we are using this one? It is used in film and photography, film and photography. Okay, now one more important, sodium nitrate, sodium nitrate, very important thing. It is also called as chili saltpeter, very important question. Chili saltpeter chemical formula NaNO3. And the last one is also alloy of, that is ore of aluminium, Na3Al F6, cryolite, cryolite. Okay, it is also ore of aluminium, ore of aluminium. Okay, so now coming to the sodium, sodium chloride, NaOH, Na2CO3, NaHCO3, NaNO3, Na3LF6, Na2SO4, 10H2O. So these are the important compounds of the sodium. Now after the sodium, coming to the magnesium. You know very well this sodium element is important for human being also. This element regulates the blood pressure. So regulates blood pressure. Okay, BP. If you take high sodium, your blood pressure is increases. Okay. And also one more important thing is, if you take more sodium into your body, then your body stores lot of water. Just now I said sodium is not available like a pure form. So it is always highly reactive element. Now it is always in a combined form. So if you want to store sodium in your body, it also stores water. 1 gram of sodium stores 80 ml of water. Okay, so if you take less sodium, then your body loses the water and you loses the weight. Okay, for example, if you are 100 kg, nearly 20 kg belongs to water only. Okay, so if you want lots of water, at least 1 year, take very less sodium, you surely lose 10 kgs. Okay, without any another diet. Okay, so sodium regulates blood pressure and also it stores the water in our body. Now coming to the next one, magnesium. Magnesium and its compound. And also students, you in the comment section, you like black theme and white pen, or this white theme and blue pen or black pen. Okay, which theme is comfortable to your eyes? Let me know. In the next sessions, I will take like that. Okay, previously I have taken the classes on the black theme with white pen. Now white theme with the black or blue pen. What you require, which is comfortable to you. Please don't forget, give in the comment section. Then according to that, I will take the future classes. Okay. Coming to this magnesium, its atomic number is 12, mass number is 24. Z is 12, mass number A is 24. Okay. And this magnesium also is also generally available in the form of chlorides, sulfates, carbonates, like that. Okay. So it generally occurs in the form of chlorides, sulfates, carbonates. Okay. And generally this magnesium is extracted from seawater. That is a very important question. Generally magnesium extracted from seawater. From seawater. Okay. Now here coming to how we can extract the magnesium. So that is from the ore of magnesium we can extract. So we have to discuss here important ores of magnesium. Important ores of magnesium. Coming to the first one, magnesite. Magnesite. Second one, dolomite. Dolomite. The third one, epsomite. Epsomite. The fourth one, carnolite. Carnolite. And those chemical formulas are very important, guys. So magnesite, so that is Mg, magnesium, it belongs to magnesium carbonate. You can simply remember with the first name. It is a magnesite. Okay, so magnesium carbonate. Here Do. So just remember some trick. Do is call it as Do. Do means tuna. So it is the carbonate of two elements. Carbonate of two elements. Already magnesium carbonate with another element is nothing but calcium carbonate. So just remember like this. Okay, we have not do the experiments, all those. Just scientists given the name with that words. So we are calling. Okay. So for example, for you, your parents given one name. Raju, Rama, Sita, whatever it may be. So we are calling. So for this, these also, they have given one name. So we have to call it. So we have to remember. But remembering is difficult. Then what we have to do? So we have to make small tricks to remember. Okay. So dolomite, do for do, it is a carbonate of two elements. Epsomite, in the epsomite domination is SO. SO means sulfate. SO means that is SO for sulfate. So remember like magnesium sulfate. SO for SO. Magnesium sulfate with 7H2O. Carnolite. Ca for chloride. For chloride. Okay, so chloride means magnesium chloride, MgCl2, and also potassium chloride with 6H2O. Okay, magnesium chloride with potassium chloride and 6H2O. Okay, so once again, magnesite, MgCO3, Do for Do, so it is a carbonate of two elements, magnesium carbonate and calcium carbonate. Epsomite, SO for SO, SO for SO, magnesium sulfate. It is also called as Epsom salt. Epsom salt. Okay. And carnolite, magnesium chloride potassium chloride with 6H2O. Okay. And where we are using this magnesium? This magnesium generally used in fireworks and also by making the flashlight. Making flashlight. And its compounds are useful in so many applications. Okay. So coming to some main use of magnesium. Magnesium only in element form. Okay, not in compound form. In making flashlights. Flashlight in photography. Okay, and also in fireworks. That means firecrackers. Okay, so it gives which color? White color. Okay, why? Because it is white colored, extremely glazed material. Glazed material. Okay, now coming to some important compounds of this magnesium. Magnesium compounds. Magnesium compounds. What are the important magnesium compounds we have? First one, very important, magnesium hydroxide. Magnesium hydroxide. Okay, magnesium hydroxide. So it is also called as the solution of magnesium is hydroxide is called as milk of magnesia. Solution of magnesium hydroxide is called as milk of magnesia. That is MOM, milk of magnesia. Okay. So what is this milk of magnesia? It is the medium base, guys. Its pH is very nearly equal to 10 to 11. That means medium base. Medium base. These medium bases are very much useful to human being. Why? Because it is used as antacids, antacid, and indigestion syrup. Indigestion syrups. Okay. So whenever a person is suffering with acidity, then those pH levels is very low now. So if you use some medium base, then pH is nothing but very nearly, it becomes nearly to 7. That means we can recover from acidity. So antacid is nothing but anti-acid. Anti-acid. Okay, that is nothing but base. So it is especially used as antacid and indigestion syrups. Okay, very important question. And the second one, magnesium sulfate. Here magnesium sulfate with 7H2O is called as epsomite or Epsom salt. Epsom salt. It is mainly used in fertilizers. Fertilizers and also ceramic industries. Ceramic industries. We use this magnesium sulfate. Okay. Now coming to one more element, that is calcium and its compounds. Calcium and its compounds. Very important. Calcium is very important, guys. Very important. Here we may get calcium hydroxide, bleaching powder. All those are very important. Yes. Here coming to calcium. Calcium atomic number 20, mass number is 40. Okay. Z is equal to 20, mass number is 40. And here some important ores of calcium. And you know very well, calcium also important for our human being. Okay. To strengthening the bones. To strengthen the bones, calcium is very much to strengthen bone. Calcium is very much needed. Okay, some important words of calcium. The first one, limestone. Here, one more important trick. So remember this one. Whenever you have the word lime, the lime is belongs to calcium only, guys. Okay, if the name is with starts with lime, that is belongs to calcium only. Limestone, calcium carbonate. It is also called as marble. So in the marble, what is the main chemical is there? That is calcium carbonate. And we have already discussed dolomite. Dolomite is the magnesium carbonate with the calcium carbonate. Correct. And here one more important, gypsum. Gypsum, calcium sulfate with 2H2O. Half H2O is the POP. Okay. And fluorspar, calcium fluoride. Okay. And this calcium is like a soft and silvery white metal. Silvery white metal. Okay. Coming to some important compounds of this calcium. Some important compounds of this calcium. The first one, calcium oxide. Calcium oxide. So it is also called as quick lime. Very important. Which is the following, which is a quick lime. That is calcium oxide. Okay. Why? Because this calcium oxide quickly react with water. Quickly reacts with water. So that's why it is called as quicklime. Okay. So whenever this calcium oxide react with the water, it will give calcium hydroxide. This is called as flaked lime. Flaked lime. Okay. So the second one, what you got? Calcium hydroxide. Calcium hydroxide is also called as flaked lime. Flaked lime. And its suspension, its suspension, it is in the form of liquid, is called milk of lime. Milk of lime. It is also used in antacids. Okay, in some antacids, calcium oxide also used. And it is generally used to make bleaching powder. Used to make bleaching powder. Chemical formula very important. Calcium oxychloride, CaOCl2. So whenever this calcium hydroxide react with chlorine, it gives calcium oxychloride plus H2O. So it is called as bleaching powder. Bleaching powder. All these formulas are very important. Quicklime, calcium oxide, CaO, slaked lime, calcium hydroxide or milk of lime, calcium hydroxide. We used to make bleaching powder. Bleaching powder chemical formula CaOCl2. Okay, CaOCl2. And what is the use of this bleaching powder? I think you know very well. Bleaching powder used to make the water germs free. So how it be possible? If you add this bleaching powder into the water, then again calcium hydroxide and chlorine gas is released. So this chlorine gas kills the germs. This chlorine gas kills the germs. So then water will becomes germs free. Okay. So if we add bleaching powder to water, chlorine gas is released, it kills the germs, so water becomes germs free. Germs free. Okay, are you getting? So let us take in the equation format. Whenever the CaOCl2 is reacted with the water, gives gain calcium hydroxide plus chlorine gas is released. This chlorine kills the germs. You may have the doubt, sir, why we are adding the chlorine to that one and making bleaching powder, again adding to the water and getting chlorine. So directly from the chlorine we can kill the germs now. So for that we have to take the cylinders of this chlorine. Okay, that is gas now. So we have to store in the cylinders and we have to take that into the water. But that is also all the gas may not enter into the water. Correct? So then in that case only we have to store that chlorine in the form of powder. That powder is called bleaching powder. Okay. So chlorine gas is storing in the form of powder. That powder is nothing but bleaching powder. You can simply add the powder into the water. Na? You can simply add the powder into the water. So in that case, chlorine is released. So that kills the germs. Okay. And the next one, calcium carbonate. Calcium carbonate. CaCO3. Okay. This is also called as limestone or marble. Okay, so it is like a white color. It is in white color. So as the name of stone, it is not at all soluble in the water. White color, insoluble in water. So that's why the marbles are used for flooring purpose. Okay, house flooring purpose. And also some building material. So used as building material in the form of marble. The form of marble. Okay. After this, one more important compound of this calcium, very much important, gypsum. Gypsum used in cement industries. Okay. Generally in the cement industries and also nowadays for decorating purpose also we are using. Industries are and decorating walls or building and making idols. Okay. And gypsum chemical formula. calcium sulfate with 2H2O, guys. With 2H2O. Whenever gypsum loses water, when gypsum loses water becomes POP, plaster of Paris. Plaster of Paris. Okay, that is CaSO4 2H2O is losses the water, then you will get CaSO4 half H2O plus 1.5 H2O. So this is the POP. POP. Okay, so don't confuse with the formulas. 2H2O is the gypsum, half H2O is the POP. Okay, so then how to avoid the confusion? A small trick to remember. Where we are using the POP? So whenever any bones are fractured into two, okay, into two, that is half and half. Whenever the bone is fractured into half and half, then we have to use the POP to give the mechanical support. Correct? You know very well, bones may not attach as its own. Sorry, may not attach with any medicine. Whenever you place the two bones together, and if you give the mechanical support to that within, that is 2 to 3 months, then the bones will be automatically attached by natural process. Our body having that strength. Correct? So that is whenever the bone is becomes half and half, then we are using the POP. Okay, so that is a thread. We have a thread. Upon the thread, the powder of POP is there. Okay, that is rolled on the hand or the part wherever it is broken. Okay, and they will add some amount of the water. Whenever they add the water, for POP, if they add water, then what will becomes? It will becomes like a gypsum. That is a strong, hard material. It will becomes hard. That means it gives the mechanical support. That is nothing but gypsum is like a cement. Okay, gypsum is like a cement. So it gives the mechanical support. So that means whenever there is a half and half, that is bone is half, we are using the POP now. That is half belongs to CaSO4 half H2. CaSO4 half H2. So this CaSO4 half H2O for this POP, if you add water, then what will becomes? And half H2. One and half H2O. If you add the water, it becomes CaSO4 2H2. Again, gypsum is formed, that is hard material. Okay, and also nowadays this POP also using for decorating purpose. POP using for wall ceiling decoration. Decoration. Okay, so these are the very important uh, compounds of this calcium. Okay, so once again, guys, coming to the metals. Metals are hard, ductile, and good conductors of electricity and also heat. What is meant by ductile? Which enables us to make very thin wires. Gold is the most ductile element, and those chemical properties, and sodium and its compounds. Okay, here baking soda, washing soda, caustic soda. That means here we can simply get the idea. Soda is belongs to sodium. Okay, soda is belongs to sodium. So you can make here soda is belongs to sodium. And now coming to the magnesium. Magnesite, dolomite, epsomite, carnolite, and compounds magnesium hydroxide and Epsom salt. Calcium compounds and ores of the calcium limestone, dolomite, gypsum, fluorspar, and quicklime, slaked lime, and bleaching powder, gypsum, and plaster of Paris. Okay. Okay, students, we will discuss the remaining in the next session. In the next session, we will take aluminum, copper, and iron, and their ores and also compounds. Okay, and students, don't forget to give your suggestion in the comment section. You want black theme with white pen or white theme with blue or black pen. Okay. Okay, students, thank you so much for watching. Take care. Bye.